The recent project is part of the Trustworthy Autonomous Systems Hub that explored critical aspects of resilience in autonomous systems. Our focus has been on physical assistance of robots in social care settings. The recent project enabled us to continue our work on the safe physical human-robot interaction. This was particularly facilitated through our collaboration with North Yorkshire County Council. With this collaboration, we were able to gather sufficient data to understand the collaboration details between the robot and the human, but also to understand barriers to adoption of such robotic autonomous systems in this particular context.
Strategically, we really want to understand about robotics and social care. We need to plan and work towards a future where robotics are a part of that social care ecosystem. Operationally, we want to be part of the research. We want the research to be really well informed by how social care workers, occupational therapists and care providers work in context, how they move, how they communicate and how they interact with their environment and the people that they're working with. And that means the research will get it right and be embedded in proper practice.
At the beginning of the project, we designed human-to-human dressing trials where we recruited healthy participants to mimic stroke patients with restricted mobility in the upper limb, and we invited the occupational therapist to assist them with the dressing. The data collected from these trials were used to design the control strategies for the safety controller, where the robot replaces the movements of the occupational therapist. We then tested the safety elements of the robot and verified the functionality through repeated experiments with healthy participants in our lab.
My involvement with the teleoperation dressing started with the medical project, which was aimed at addressing medical triage tasks, but we saw some downsides with the teleoperation aspect of using robots, and we transitioned from teleoperation to autonomous systems with the recent project. And we used the stroke patients as a case study where we help these patients to put on a dress with the help of these collaborative robots.
We have developed computer vision algorithms that are able to estimate the pose of the human, and this information, these estimates are used by the robot to help the person to accomplish the dressing part. We tested and validated the resilience of the algorithms under different environmental conditions, and in this way we have proposed methods that have a level of trustworthiness, so we know when they work well and when they work less well.
We use a digital twin, which is a virtual representation of the physical system, to help us collect data and make decisions about the process. In particular, we track the human and we pass the information on the human's position back to the system. And using the twin, we can identify then safety zones, which we can use to control the robot and also provide visual feedback to a user.
By means of a digital twin, we've been capable of presenting to the user information such as trajectory covered by the gripper of the robot. These features are capable of improving the trustworthiness towards the robot, but also the perceived usability of the system.
Our collaborations and insights obtained from the recent project open up many new avenues of technical and socio-economic aspects that need further interdisciplinary research. Our current and future work will expand the use of multimodalities to enable safe human-robot and human-AI interaction in healthcare settings.